So, Arthur Ashkin invented the optical tweezers. And he did this in 3 steps. If you look at the upper panel, he realized that he could, using the radiation pressure from a laser, and push a small micro-sized transparent sphere in the direction of the laser beam. He also realized, in the middle panel, that because the laser beam is not homogeneous, it's more intense in the center. The sphere will be pushed into the center by so-called gradient forces. And finally, he took a lens and focused the beam so that he could keep the small sphere fixed in space. And we will now make a small demonstration of this using a hairdryer and a ping pong ball, and it will be my colleague in the committee, Anders Irbeck, who will do this demonstration. And please note now that he can tilt the hairdryer and still keep the ping pong ball under control. This is a simple test you can do yourself at home if you want. So, of course, it wasn't the fact that he could trap a small sphere that was the real breakthrough. The real breakthrough came when Arthur Ashkin demonstrated that he could trap in the tweezer, that he could trap viruses, bacteria, and even living cells. And this led to a very interesting development, very important development. And here we will demonstrate what happens if we take a molecular motor. This is a molecule that is doing work in the cell. In this case, it's a kinesin, it's a protein, and it's attached to a sphere, which is now in the optical tweezers. And the molecular motor will now start to walk on a cellular cell skeleton, but feeling the resistance from the sphere. It's like a gladiator contestant strapped with an elastic band, and you walk and it becomes more and more heavy to walk because the force is pushing you back. By doing this experiment, it was possible to measure the force between the cell skeleton and the kinesin molecule, and it was also possible to measure the step size.